Hello everyone, June 26th. Let's do this. Longest subsequence repeated k times. You are given string s of length n and integer k. You are tasked to find the longest subsequence repeated k times in the string. A subsequence, we know what a subsequence is, but derived by the deleting, right? A subsequence is repeated k times in the string s if the sequence times k is a subsequence of s, where this represents a string constructed by concatenating this one k times. For example, BBA is repeated 2 times in the subsequence because the string BBA constructed by concatenating this 2 times, and that is a subsequence of the string. Return the longest subsequence repeated k times in string. If multiple such subsequences are found, return the lexicographically largest one. If there's no such, return an empty string. So our example is, let's LeetCode. Okay, so we want the longest to repeat 2 times. Well, we can analyze the frequency first, right? So analyze the frequency. So it has to be divisible. Yeah, it doesn't really matter because it's subsequence, right? It's subsequence. And when you do a subsequence, I think you cannot have another one inserted into it, right? Because that's a subsequence. Yeah, this is a subsequence. So basically we need to divide it into k subarrays, right? K subarrays. So hold on, let me try this. So let's say we have LET and LET. Right, the longest will be TT. It's such a good test case. All right, come in. see, that test case, is that TT? Oh, no, it's not TT, it is T, right? It's not LET, so that makes sense. So basically, what you want to do is divide this into K subarrays, right? And within each subarray, you need to have the same subsequence. Okay. We have n subsequence. So you have to divide it into something, right? Like in this case, you have to divide it into 2 parts, which means one part has to start from the beginning and then goes into, we don't know where, right? So if it is by itself, then you're basically trying to see if we have another one in it, right? And then you start to add more to it. You're trying to see if similar pattern can be found. I don't feel like that's the right way. Well, you can exclude the letters that have smaller than K, right? So those are easy cases, you can just ignore. And then you want to find the longest. The subsequence, right? Could be many choices. I mean, I can have the indices of all the letters, right? I have indices of all the letters. I have indices of all the letters. What does indices help? So we can choose a starting point. Okay, I choose a starting point, then I know where the second one will be. Then know by the starting point, we actually get all the subarray. Already get, like in this case, by choosing L, we have this and we have this. These are the two subarrays, right? And then we can keep going. What do you mean by keep going? I'm trying to find the next one. As early as possible, if you want to match. Okay, now you match. And you try to match the next as early as possible. And then you keep going until you run out of matching. So that's the longest subsequence that can match. So basically, after you choose a starting point, you get a bunch of subarrays, right? Now you're just trying to find the longest common subsequence, right? Just try to find the longest common subsequence among all of them, where the first one is all the same, right? Longest common subsequence. But I believe the longest common subsequence runs in OAV time, MN time. Basically, you try to compare if these two are the same, then you move on. If they're not the same, you do the cross matching, which means once you secure this, yeah, that's gonna take a long time because, like, you got this, but you have to consider this, right? Longest common subsequence of these two, longest common subsequence of these two, and K can be huge, right? K can be huge. It definitely can't just do longest common subsequence. We need something that, like one pass can tell us. Yeah, you have a bunch of longest common subsequence. Doesn't seem right. You can do a longest common. Basically, it's longest common subsequence over K over arbitrary number of arrays. How are we gonna do that? Are there any restrictions that make it not a full longest common subsequence problem? Because we know a full longest common sequence problem is O(n) squared, right? It's not going to work. Or maybe we can frame it. For example, we do, like, how many different, we do the longest common subsequence of the first two. Well, you can have a lot of different options, right? You can have a lot of different options. Yeah, I don't see how that's possible. All right, I don't have much idea. What's the hints? The length of the longest subsequence does not exceed n divided by k. Does not exceed n divided by k. The length of the longest subsequence. Well, you divide it into k subarrays, right? If, so we had to do n divided by k. N divided by k is like you divide it evenly, right? Because if the longest is longer than, yeah, then it exceeds the total length, right? That makes sense. Okay. So we know the length of the subsequence, right? Yes, length of the subsequence, and we find the characters that could be included in the potential answer. Okay, I got that part. Try all possible candidates in reverse order and check the string for the subsequence. Condition, try all possible candidates. What the hell do you mean, all possible candidates? I don't understand. So we find the largest letter, and let's say it has a count. So we divide by k, we know how many times at the most it can be included. Alright. Then we say we'll include it twice. Let's say we have like 2 times. Okay, so we include them twice. But then what? What do you mean by try all of them? Like in this case, right? T is the largest, right? T is larger than T have 2. So, and we divide by, so each should have 1 T, right? So each have 1 T, and I need to start with T, right? We start with T. So, okay, so I have 1 T is here. You know what? Let me remove all this. So we start with T, and we know 1 T is here. 1 T is here. Okay, so we start with T, okay? And then, doesn't matter we have how many. But yeah, that's the thing, if we have more T, then we can have different combinations, don't we? Right? We have different combinations. Yeah, I don't understand. Okay, there's also one more hint to the topic. Greedy backtracking. What? Alright, I don't know. Let's check the answer. For the longest subsequence of characters that appears at least k times in lexicographically largest, therefore the characters that make up this subsequence must appear at least k times in S. Characters that appear fewer than k times can be filtered out. Yes. Let the length of S be n, we only consider character in S that appear at least k times. The longest valid subsequence can only be composed of these characters, and their count cannot exceed n divided by k. Since the problem states that n smaller than 8k, you're kidding me. I was wondering what this one means. So n divided by k is smaller than 8, which is smaller or equal to 7. So the longest subsequence, right? The longest subsequence cannot exceed 7 characters. Cannot exceed 7 characters. But it doesn't really matter because we will do this thing, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. S is 12, right? 12 divided by 2. Wow, it's 6. So long substance cannot exceed 6. So in here, cannot exceed 7. So it has to be smaller or equal to 7. Okay. Smaller than 7. Then what do we do? Oh, smaller or equal to 7. I still don't know. Therefore, the number of candidate subsequences, does not exceed 2 to the 7. Huh? The number of candidate subsequence. I don't know how you come up with this 2 to the 7th power. And the number of qualifying characters is also at most 7. The valid subsequence must be at most 7, and the number of qualifying characters is also at most 7. Therefore, the number of candidate subsequence. Okay, I don't understand. The number of candidate subsequence does not exceed 2 to the 7th power. What? How did you get there? Okay, let's keep reading. We start by counting the frequency of each character and identify those that meet the required threshold. Then we enumerate all possible permutations formed from any combination of these characters. For each such permutation, we check whether it appears in at least k times. Among all valid, we return the one with the maximum length and the greatest lexicographic order. Huh? Okay, so we have a limit on the size of the subsequence, right? It's okay. The subsequence cannot exceed a certain length, all right? Then we go through everything, and then we find all the letters that is possible to. It's basically a count is larger or equal to k, right? Is larger or equal to k. Yeah, it's larger or equal to k. Okay. So now we have these. But you want a permutation of them. Like we have 26 letters. Right, we have 26 letters. Like the maximum case, we have 26 letters. And we shall be able to 26 choose 7, like the maximum case. That's a big ass number. I mean, whatever you have, then we say, well, pick whatever number is like the longest, but it doesn't have to be 7, right? It doesn't have to be the longest. It can be this, it can be smaller. Like how you come up with 2 to the 7? That I don't understand at all. Alright, I have to read this. So we get that. That's fine, I understand this. What the hell is this? Okay, this is the candidate. Okay, I understand the candidate. For everything in. What's this? What string is string 1? What does this mean? Repeating a specific character a certain number of times. Anyway, it's just each character, each candidate repeated once. Okay, we get that. If larger than answer dot size. We do that. Generate the next candidate string. For everyone, the next is current plus you just append it to the end? What happened to permutation? What happened to permutation? This is not, is this permutation? What? You just put the candidate to the end. Like, why isn't it reverse order? Oh well, because you go through everything, and then everything goes through everything, and everything goes through. Ooh. Because every possible permutation can be created if you go through that number of times. Right? So you have an array of characters, and you want to find all permutations with repetition, actually, right? With repetition, then you just go through everyone and go through everyone, just append to it. So like you have, there's actually, okay, I should take it, I think that's quite brilliant. You have ABC, right? I want to find all permutation of ABC allowing duplicates. So what you do, I take A, I take B, I take C, right? That's the first round. Second round, I have, when it's A, I have AA, AB, AC, right? And then we have BA, BB, BC, and we have CA, CB, CC, right? And then if you want another round, then AA can get AAA, AAB, AC, right? ABA, ABB, ABC, ACA, ACB, ACC. And that's how you produce. I think I know what it means by 2 to the power of 7. I think I know. Right? Because if length is 3, hold on, I don't think I know. Length is 3, so we have, we have ABC, that's 1, and then we have this, that's already 9, right? Okay, I still don't know why they say 2 to the 7th. Because eventually you have a permutation. This position can have however many, like this is like 3, have 3, and this is also 3, this is also 3. This is like 3 to the 3rd, right? That number of different ways. Actually, not that's 3, right? That's 3. Well, I mean, depending on if you can even produce that much. And you also have 2, which is 3 to the 2, and we'll have 3 to the 1. It's this. This is the total number of permutations you can have. And this is exactly what you're doing. You just put it at the end, and you would check if I have that number of. Oh, how do you even check that? Well, you check to see. Yeah, it's greedy to check. You just, go from left to right. You find one and you find one. I think that the check we got. You just go greedy. Yeah, it's plus plus. And if this you reset, match. If it's yep, the check I understand. But that 2 to the 7th is definitely not right. It's definitely not right. Plus, that's not true, right? That's not true. The I combination of string of length I. No, that's not true. Because you allow repeats. If you allow repeats, that's not factorial. That's to the power. I don't think that's right. I don't think that's right. What I think is basically what it's saying is you get all these possibilities, right? We get all these letters that are possible. And then you just go through like, okay, what if it's 1? Hey, they even check 1. They even check 1. Do they even check 1? They actually do. They actually do. That's one of them. Okay, yeah. So now we say, okay, now give me 2, right? Length of the subsequence is 2. Give me length subsequence is 2. So you do all the permutations, but that's not just permutation, but also you allow repeats, right? So you get all of them. Then there's 3, then there's 4, and there's 5, and at most you get a 7. But at each time, what you get is at most, right? At most we have 26 characters. So it's 26 character. So it's gonna be what is this? I forgot the formula. So like a to the 1 plus a to the 2 plus a to the, let's call it 7, right? Because that's the most you can get. And this one can be, if I remember correctly, it's, I don't know, I have to redo this. So basically we do a times s plus a2 a8. So we say as minus s is equal to a8 minus a. So s equal to a8 minus a divided by a minus 1. Right? So that's the answer. So now a, the largest a will be 26. So it's 26 to the 8th power. Right? What's that? What's that? 28 to the 26 to the 8th power minus 26 divided by 25. This is the maximum you can get. Well, I mean, they also have restrictions on the size, right? Restriction on the size. So its largest is 2,000, right? And largest is 2,000. So if you have a 26 repeated for stopping, let's say A B C D to Z, and A B C D to Z, and A B C D to Z. We just keep doing this. Oh, this length is restricted. It's not the number of, it's the length. Like this cannot be 26. So A cannot be 26. I think I misunderstood this. Yeah, at most is 7, right? You can have at most 7, and the length is 7, so this A is 7. So A is 7. It's 7 to the 8th minus 7 divided by 7 minus 1. So that probably is an okay number. So let's say 7 minus 7 divided by 6. Yeah, this is a possible number. This is a possible number. What do people say? Hold on, for any string of length 7, the total number of possible subsequence. Yeah, this is not right. I'm gonna post something. I don't think it's right. I don't think the time complexity is correct. Permutation, n factorial applies to permutation, right, with a non-length. How do I say that? The way the permutations are created is like this. No, hold on. say we have A, B, and C as candidates. The way the permutation is created is A, B, C, and let's say the length is 3. So we have as candidates, and the maximum the maximum length of the subsequence, right, is 3. And the way the permutation is created is, actually it doesn't even consider the longest. Right? ABC, AA, AB, AC, BA, BB, BC, CA, CB, CC, and then AAA, AAB, AAC, ABA, ABB, ABC, ABB, ABC, is AB, ACA, ACB, ACC, BAA, BAB, BAC, BBA, BBB, BBC, BCA, BCB, BCC, CAA, CAB, CAC, CBA, CBB, CBC, CCA, CCB, CCC. Right? Which this is equivalent to 3 to the power of 1 plus 3 to the power of 2 plus 3 to the power of 3. Right? 3 to the power of 3. In other words, theoretically, the max number of operations, max number of permutations we can encounter is 7 to the power of 1 plus 7 to the power of 2 plus 7 to the power of 7, which equal to this number. Of course, in reality, not all the permutations get to continue, so we don't have to go through all of them. But I don't think the complexity but the but a number of possible string combinations is not the sum of m choose I times I factorial, because we allow repetitions. We allow repeated, right? Repeated characters in a subsequence. Unless if we don't allow, actually I'm not sure. Are we allowing repeated? I think we definitely do. For example, this will give me LL, right? Yeah, we are allowing. The editorial, the number of permutations explained in the editorial is based on the assumption that within each subsequence, each character can only be used once. Hence the formula sum m choose I times I the factorial. But the problem does not have this restriction. And since we can use, since each character is allowed to repeat, right, the total number of permutations is much bigger. For example, in other words, the number of permutations has the time complexity of O m to the power of m. Right? And since the largest m is 7, with the largest m being 7. All right. Did you say in other words 2 times? Not all the permutations will be encountered, but should have complexity. All right, do you want to solve this? Actually, I don't. I'm going to copy and paste because I understand what this one is about, so there's no point. This is a copy and paste, but I understand what the solution does. In fact, I left a comment under the editorial questioning the logic, questioning the time complexity of the total number of permutations. The solution essentially brute force, right? Brute force the problem. It finds all the letters that appear at least k times in S, then it finds not all the letters, just say it finds the letters, then it produces all possible permutations of subsequences of all possible lengths with all allowing repetitions repetition of each character, right? A subsequence of all possible lengths allowing this, right? Then it checks whether the produced permutation of strings, right? Produce a string can serve, right, as a subsequence that occurs at least k times, right, in us. The generation of permutation is straightforward as such. For character in candidates, all right, for character in candidates, straightforward, right? Each time a previous permutation is good, right, we use that as the base to produce the next round by appending each candidate, right? Appending each candidate to the end. The check, right, whether a string appears at least k times in S as subsequence, right? As subsequence is done in a greedy way, right? We scan S from left to right and always try to match the string as early as possible, right? As early as possible. And yeah, and once we have k matches, right? That means the string is good, right? Is good. The total runtime, the time complexity, right? Complexity in my book should be O n times m to the power of m, where m equal to n divided by k, which in this problem it does not exceed 7. Alright, I will at least just put it there, but I'm not gonna code it up. Simply because this is I mean the coding part I think it's pretty rudimentary. The idea, yeah, I don't know about the idea. But I don't really like this problem. I don't really like this problem. So this is my thinking. It could be wrong. But I mean just look at this, right? This is m choose I. And m is the total number, so like you're choosing I and you do this. This is like you are not allowing duplicates for letters, but if you check here, you're going through every single one, right? You start from all the candidates and then you append all the candidates. So that's why this is not right. Anyway, that will be it for today. I will see you guys tomorrow. I think this is the one I'm not gonna upload. I think okay, I think the problem is all right, but the editorial, I'm gonna download the editorial. I think the time complexity is not correct. I left a comment explaining my thought. I could be wrong, but I welcome further discussion. Alright, that'll be it. I'll see you guys tomorrow.